Alright guys, now question 3 ke. So this is a question paper yaga exemplar for grade 12. In the description below uzothola ama links for amanye ama questions wakule question paper le. Right, okay, lana sikhuluma nge-projectile motion, a bouncing ball. According to this sketch yabo ukuthi sinama curve la, or sinama qanda or ama oval. Sikhuluma nge-bouncing ball la. This is a position versus time graph. Right, question ethi ifundeka ngale ndlela le ithi a ball of mass 0.5 kilogram is projected vertically downwards. Well, there's someone mhlambe umile at a height, it might be a balcony, or umuntu wakhona mhlambe umile mhlambe phezu kwe-wall kanje, so and then uprojector a ball ekwazi ukubounce from that height leyo, we projector downwards towards the ground from a height of 1.5 meters at a velocity of 2 meters per second. So we are projected downwards at this initial velocity. So now the position versus time graph for the motion of the ball is given below. So lana's in a position versus time graph. Siyabona ukuthi lana the individual ume at a height of 1.5, then you projector the object down, nakai projector you figure bounce, and then that ball is over in contact with the surface for a period of t1 to t2, then it bounces up, or it bounces all the way up to a height of 0.9. Then le ball aliphinde libuye futhi lenzeni libe in contact with the surface for a specific amount of time, and then ibouncela phezulu again. So now thatha ukubheka la sina how many bounces now, 1 2 bounces. This curve it represents the motion of the ball the moment iba projected. So see now 1 2 yama bounces on this position versus time graph. So with 3.1, what is the maximum vertical height reached by the ball after the second bounce? After the second bounce, first bounce it reach this height, second bounce it reach in this height of 0.5 meters. So this is question 3. Question 3.1. The answer lana is 0.5 meters. It's 0.5 meters. Now what is lana? Calculate. So 3.2 now. Calculate the 3.2, but calculate the magnitude of the time t1 indicated on the graph. So lana T1. All right. Lona T1 lo, ne? T1 represents the time the ball takes to move from height 1.8 all the way down to the ground. That's T1, ne? It's the time the ball takes from the moment it gets projected all the way up to the ground. That's T1. Ne? So in order to calculate T1, kumele sebenzise the information of this curve, ne? Of this curve. 3.2 asithathe i-data kuqala ke. Data but lo d wami ufana no r. So now ufunda la, if this is RATA, it reads as rata, but intention yami ukubhala udata la. So let's take out the data. Sine VI, we have initial velocity which is 2 meters per second. Oh, by the way, I'm taking up as positive, né? I'm taking the upward direction as positive because the ball is projected downwards, so 2 meters per second is over negative. Therefore siba no delta y, the distance, kuyoba minus 1,8 meters. Remember the delta y, the distance is over in displacement, right? I'm saying negative 1,8 because the ball is moving downwards and the displacement is over downwards. So that's why I need to delta y is about negative 1,8 meters. It's going down. The delta y is also a vector. It's a displacement. Okay, ngiyaqhubeka-ke manje. Then siba no g. G is also acting down. It's minus 9,8 meters per second squared. Sifuna ini thina? We want T1, unknown value. Ne? The unknown value. Alright, asize ngapha ku formula sheet. Equations of motion. Now, these are the equations of motion. So, do I have a final velocity? No, I have the initial velocity for sure. Acceleration, time. So this equation ayeki 7. V final anginayo, so also this equation ayeki 7. Do I have with delta x? So because I chose with delta y, so ngizobheka this equation. Do I have delta y for sure? Do I have initial velocity? Yes. How about delta t? It's what I'm looking for. And then acceleration now. So I can use this formula 80. This one 80 delta y is equal to v initial times delta t plus half gravitational acceleration, or you can use a. Ungasebenzisa a if uyamfuna delta t. So now let's calculate for t. So last we have a quadratic equation. So delta y it's minus 1,8. Initial velocity it's minus 2. Delta t plus 1 over 2. G it's minus 9,8 delta t squared. So therefore it's a quadratic equation now. But let's simplify equation here too. So we're on negative 2 delta t, and then it's half 0,5 times minus 9,8. It's negative 4,9 delta t squared. So let's rearrange this equation. It's a quadratic equation because of the t squared. So okay. Move everything to one side of the equation. So the contents on the right hand side of the equation to the left. So we have a positive 4,9 delta t squared plus 2. This is 2 delta t minus 1,8 equal to 0. So therefore delta t is equal to quadratic equation to simplify. Minus plus minus b squared minus 4ac divided by 2a equal to minus b, it's 2 plus minus b, it's 2 squared minus 4, a is 4,9, and then c it's minus 1,8, or divide by 2a 4,9. So let's calculate here. Minus 2 plus square root 2 squared minus 4,5 minus 1,8. 2 times 4,9 is equal to, in two decimal places, my answer this is my answer, 0,44 seconds. So this is T1. Actually I want it's plus minus. Mina ngisebenzisa the plus one. Ngisebenzisa leya ka plus. How about leya minus again? Leya minus answer izophuma izoba negative, and then isikhathi yakhonakala ukuthi ibe negative. So that's why ngithi answer yami it's this one. There's only one solution here, not two, only one. So the other one in negative angikhona ukuyisebenzisa because time cannot be a negative value. So 3,3. What's the question? Calculate the velocity with which the ball rebounds from the ground during the first bounce. Okay, athinga. Sifuna yiphi velocity? This velocity or the velocity with which the ball rebounds from the ground. Okay, this is the first bounce, ne? So thina sifuna the rebound velocity. Le ball liyeza lifike libounce lana. Sifuna the velocity of the ball right after the bounce. So sifuna the initial velocity for this part of the graph, ne? The initial velocity after the first rebound. So sebenzisa the information of this graph for this curve. This one ayesisebe, so sebenzisa only for this one because ufuna le velocity yala, the initial velocity. So check out manje. Data. It's always important to keep a data when doing our calculations with vertical projectile motion. So 3.3 velocity. Okay, asizelana again. For this curve, siyabona ukuthi the ball when it reaches this point 0,9, the final velocity kuba ubani? The final velocity becomes 0. Again, I'm choosing up as positive. Ne? I'm choosing up as positive. So final velocity is 0 because at delta y equal to 0,9, that's the maximum height. So final velocity kwamele ibe ubani? Ibe u0. Delta y uzoba positive this time because the ball is going upward. It's going upward. And uma iya phezulu, I chose up as positive. So that's why delta y this time aba positive. Let's continue taking out the data. Sibano g, which is minus 9,8 meters per second squared, up as positive. G is always acting downward. What else do we have? Okay, asebenze nale information le. Mina I'm looking for initial velocity. Asibuyele la kulama equations wethu of motion. Okay, ke ngifuna initial velocity. Do I have a final velocity? Yes. Do I have acceleration? Yes, but I don't have time. Lesikhathi lesiya esisicalculate on the previous question, it was for this curve, and the t represents t1, not bani t2. Okay, do I have a final velocity? Yes. Initial, no. Yiyo. How about acceleration? Yes. So singasebenzisa that one. So sebenzisa this formula 80. V final squared is equal to V initial squared plus 2a delta y minus 7 to g, and then final velocity is 0. Initial velocity, it's the value engifunayo, 2 minus 9,8 delta y, it's 0,9. So it's 0. V initial squared, it's going to be minus. So it's 2 times minus 9,8 times 0,9. So answer it is, it's funny. Okay, it's minus 17,64. 17.64 transpose yofika ngapha ithi 17.64 equal to v initial squared. Square both sides, answer yami yoba izothi v initial is equal to 17.64. My answer is 4.20 meters per second. In which direction? Up. The answer is 4.20 meters per second up. Remember, if value yami iphume as a positive value and I chose up as positive, and the rebound velocity na pointer upward. So now final velocity here today. The final answer here, not the final velocity, but initial velocity, and it's our final answer for this question. Now, so with 3.4, but there's a statement like what if the ball is in contact with the ground for 0.2 seconds during the first bounce. First bounce, this is first bounce, né? And it takes 0.2 seconds. So this flat line, né? This line from T1 to T2 is 0.2 seconds. This is the contact time. Asho nokubona i-tennis ball or ibhola uma ngabe liyoba in contact with the surface lenzani liyasquasheka. So then after getting squashed, i-ground izowenzani, izo-apply an opposing force so that le bhola lenzani liya-expanda futhi bese lenzani liyaphezulu again. So therefore lana the 0.2 seconds, that's the time when the ball was squashed again. That's the contact time. Right, 3.4. Calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at 6.27 meters per second. So in other words, batikiti, I change this. So this is 3.4. Check out. So on the curve, sina something efana nale. This part of the graph, ne, yizumile vu, ngathola something efana nale. T1 and then here's T2. The contact time between T1 and T2 is 0.2 seconds. So gava this cock, gava. This velocity, ne? This velocity before the ball strikes the ground, it's what? It's 6.27 meters per second. And then this one is start to calculate. If velocity alana ubani after the first bounce, it's what? So calculate as what? As 4.20 meters per second. Now we get to button now. Calculate the magnitude of the force exerted by the ground. So lana sikhuluma ngani? Take a guess. Sikhuluma ngani? Sikhuluma ngo F net times T. Force times T is equal to what? Impulse. Sikhuluma nge-impulse, ne? Sikhuluma nge-impulse la. And the impulse is also equal to the change in momentum. The change in momentum of the ball. So, right again. China sifuna ini? This force. Sifuna le force le. F net. So therefore, F net times T is also equal to P, which is the change in momentum. Check out the F net times T is equal to change in momentum is what? Is M V final minus M V initial. Ne? Initial. This is the final velocity. This is the initial velocity. This is the incident velocity, and then this is the after velocity or final velocity, right? Tina's focus are only on this part of the graph. So basiphe ngamabomi lo 6,27 meters per second in order ukuthi sikwazi ucalculate ubani u-Fnet. So I'm given the contact time which is 0,2, so I can substitute ama-value then ngithola ubani u-Fnet. Instead athi ngenze so, mv final minus mv initial divided by delta t. Fnet is equal to, what's the mass? It's 0,5. Final velocity is 4,20 minus 0,5. Initial velocity is 6, oh, interesting. Okay, again we also need to choose a direction. So up is positive, so the value final velocity is correct, it's plus 4,20, and then initial must be negative 6,27. Always choose a direction for my calculation wakho when doing momentum vertical projectile motion, even Newton's laws as well. Time is 0,2. Fnet is equal to calculator 4,20 minus 0,5 times minus 6,27 over 0,2. So is it okay. Okay, 0,5 times 4,20 minus 0,5 times minus 6,27, 0,2 is equal to, in 2 decimal places the answer is 26,18 Newton, and the answer is positive 9 in 2 decimal places. This is my answer. So the Fnet, basically what's happening like is that le ball I think thole something appropriate. Yeah, like rubber la. Imagine le rubber le as ibhola ne, le rubber le bhola nangiliphonsela phansi lizoba in contact with the surface. So according to Newton's third law, object A will exert a force on object B, which is the ground, ne? And then the ground will also apply an opposing force. Ngathini izo apply the same amount of force being applied by the ball back to the ball, but in the opposite direction. So that's why the ball nalifika past liya squashega and then it goes up again, basically bounce again. It's because the ball nalifika ku ground will apply a force, as well as the ground will apply the same amount of force but in the opposite direction, thus pushing the ball upward again. So this is the force, 26,18 newtons. In fact, I need the direction, which is up. The direction is up. Now, for the last question here, draw a velocity time graph for the motion of the ball from the time it is projected to the time when it rebounds to a height of 0,9. To the time it rebounds to a height of 0,9. Clearly show the following on your graph. The time when the ball hits the ground is cut nako nkari. The velocity of the ball when it hits the ground, the velocity of the ball when it rebounds from the ground. Okay, again. 3,5. Since I like choosing up as positive, nalana as choosing up as positive. So okay, so here's a rough sketch now. Seems like I'm trying to put a ruler around there. but anyway, okay, this is the y-axis, and then that is drawing in a velocity time graph. So the y-axis is over velocity, is represent the velocity in meters per second, the velocity in meters per second, and then the x-axis is represent what time in seconds. So therefore up is positive ngoba check le ball abal projected down, at this velocity. So what is compensate the velocity of the ball when it hits the ground, the velocity of the ball when it rebounds. Okay, for argument's sake asisho njalo ke ngizokhombisa the initial velocity as well. So this is the initial velocity, ne? And then the initial velocity is over negative. Why about negative? It's going to be negative 2. Usakhumbula velocity at a velocity of, this is the initial velocity 2. This is the initial velocity of the ball minus 2, ne? And the ball in the projector downwards. So the velocity yenzani increase. The value of value velocity yakho increase. So that's why the graph yami yakuphi yaphansi. So nayifika lapha phansi velocity yethu yoba ubani, nayi velocity yethu yoba minus 6,27. Remember basitshela la ku 3.4 bathi calculate the magnitude of the force exerted by the ground on the ball during the first bounce if the ball strikes the ground at this velocity minus 6,27. Why is it negative? Because I chose up as positive. I'm choosing up as positive. So anything eyaphansi izoba njani? Izoba negative. So le ball just before it hits the ground is reach this velocity at what time now? So khumbula calculate isikhathi at the 3,2, the time when the ball hits the ground, which is ubani, the t1 is what? So calculating 0,44. It's 0,44. This is t1. Ne? This is t1, and then siba nobani no t2. This is the contact time. T2, the contact time it's like it's 0,2. So what is 0,44 plus 0,2? 0,44 plus 0,2 is equal to 0,64. So therefore at t2 siba nesikhathi of 0,62. This is the contact time from 0,44 to 0,62. This is the contact time. So after 0,62 the ball lenzani liya rebounder ke manje. Lo rebounder ngevelocity engakanani konje 4,2. So liya rebounder ibhola lethu, and nal rebounder, so le bhola nal rebounder lisuka la le rebounder at a velocity of 4,20. So lizo rebounder at this velocity, but nalifika la ku 0,9 at the maximum height lwenzani lo reach a velocity of what? Lo reach a velocity of 0. So therefore this is our sketch. This is our sketch abasifunako ne? This is the sketch abasifunako, but sometimes nginokubona ba-connecta lama line so ne? But mina ngithanda ukwenza abe perpendicular, the dotted line. Le graph ya disconnecta la just to show ukuthi lana there's contact time. The graph lawa aya disconnecta la just to show ukuthi there's what? Contact time. Le ball was at one point stationary, so you'll drop leave a stationary line, and then it takes on a different direction. So also angazi ukuthi banifundisile eklasini ukuthi the general graphs for ama projectiles. If for a bouncing ball uba no zigzag, ne? Uba no zigzag, but zigzag wakho uzodepend ukuthi choose which direction, and then so yazi ukuthi okay, if it's being dropped you're something like a straight line kanje. So, and then for position versus time graphs, I just hope ukuthi banikhombisile lawo ma graphs in class, but for this video sizophelela lana. If nidinga ukuthi ngidiscuss amalo kanje ama graphs for projectile motion, please drop a comment in the comment section. Now we enjoy this video, leave a thumbs up. Now when a question, also drop a comment. Now we're new to this channel, please consider subscribing. Thanks for watching. Ngizokubona kule video elandelayo. Please azokunceda lama video in the description below. Please ngicela uwacheck nawo. Lawo video lawo wabona lapho, there are links for ama questions akhona kule question paper. Thanks for watching. Peace guys, peace.